Okay, so today will be our first of 3 days with factoring trinomials into two binomials. So we learned how to FOIL in 8.3, I believe, where we learned how to distribute a binomial to the other binomial. But how do we undo that using the distributive property? Well, we need to learn how to factor these trinomials so we can get back to the two separate binomials we started with. So we'll start that today, and then we will continue learning in the next couple days, actually. So that's going to be our focus this week. So to get started, we're going to be learning how to factor. Notice that in front of x, there's no coefficient. So that coefficient is actually 1. And so that's the kind we're focusing on today. And then tomorrow we'll move into that not being a 1 anymore. So what happens when I FOIL when I'm working this step out? So as a reminder, FOIL would give me, I would get x squared for my first terms. And then my outer terms would be plus 5x. My inner, that's a little large. My inner terms will give me a plus 3x. And then my last terms gives me a 15. Well, when I go to simplify though, my first term stays exactly where it is. And then my last term stays where it is because the two in the middle end up combining. In this case, they added to 8x. So today, our main focus is I'm going to start with this final answer, and I want to end up getting back to that original. So that's our focus on how do we go backwards. So part of that focus is going to be the fact that my two middle terms are like terms if I'm dealing with two linear binomials. So to get started, let's go ahead and look at a problem. So I'm going to take you through a process that is not included in your book, and then I will take you through the process that is in your book with our next example. And you can pick whichever one is easier for you. I know Mr. Wilson is going to use this first method more often than not in your Algebra 2 classes. So this first method is referred to as factoring using boxes. So to factor using boxes, what we'll do is I will put my first term in that blue box, and I will put my last term in that last box. So by doing this, it's going to allow me to find out how do I break this up into pieces. So if you are using this method, you do have to draw the boxes for me. If you're using the other method I'll show you in a minute, you'll still have to show me a good bit of work. It's up to you which method you like more. So with this one, the next thing I'm going to do is we're going to go in and we're going to multiply these two pieces together. So I do that off to the side because it gives me some space to show my work. So in this case, this gives me 12x squared. Okay, so because of this x squared here, that means in both of my green boxes over here, I'm going to have an x. So now I have to figure out what goes into the other two boxes. So what I'm going to do is I'm going to list off my factors of 12 in pairs together. So for example, it's 1 times 12 gives me 12. My other options are 2 times 6 and 3 times 4. Okay, well 12 is a positive number, so because of that, I'm going to add these together. Okay, so 3 plus 4, 2 plus 6, and 1 plus 12. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. So which two of those pairs added up to whatever my middle term is? Well, in this case, it's 3 and 4. So it does not matter where you choose to put the 3 and 4, you'll end up with the exact same final answer. So now what we're going to do, we're going to go back to my table, and we're going to look for GCFs per row. So in this first row, what's my GCF between those two pieces? Well, it's just an x. What about between 4x and 12? What's my GCF? It happens to just be 4. So then, after I've done those, we're going to go in the other direction and do columns. So x squared and 4x just gives me an x, and then 3x and 12 give me a 3. So what I've done is I've gone through and I've actually written out my factors together without even realizing it. So I'm going to erase the work over off to here to the side so I have space to show the next piece. You should not erase your work. You need to leave that piece of information, because if you just wrote down some wrong factors, that lets me know what happened to give you some partial credit. So my factors are going to be, well, this 3 I pulled out was a positive 3, and this 4 that I pulled out was a positive 4. So because of that, my two factors when factoring, this one will be equal to the quantity of x plus 3 times the binomial of x plus 4. And that is my answer. Okay, so let's go do another one so you can see that pattern again. Before I show you the second version, you can do it, which is essentially doing the exact same thing. So let's go ahead and look at another one. So here we go. With my next one, I am once again going to put my first term in the blue box. That is up top, and my other term in the bottom box. So, first thing I'm going to do is we're going to multiply those two pieces together. So that's going to give me 20g squared. So by putting the g's in the boxes earlier, that just gave me a shortcut. But what I'm really doing is I would have, for example, 20g times 1g. And then, let's see, what else? We have 2g times 10g. 3 doesn't go into 20. 4 does, because it's 4 times 5. And that'll be all of my factors of 20. So, because 20 is positive, we're going to add these together. So we would add them, add them, add them. So, which of these pairs adds to 21? Well, that, in this case, is going to be my first pair. So, I will write 20g and 1g. The order in which you put these into the boxes isn't going to hurt anything. You'll get the correct answer no matter what, as long as you're being careful. So, my first row has a common factor of g. My bottom row has nothing in common except 1, and that's okay. Ones are going to show up. And so then my first column has a common factor of g, and my second column has a common factor of 20. So 20 was positive and 1 was positive. So that gives me my final answer of g plus 1 and g plus 20. As long as those two binomials are together, we're good. We just don't want them separated. Okay? So this can be a lot of steps. And so on the next slide, it's a lot of words, but really it's going through and just taking you through the steps that we just did in a lot of words. So when I show the next slide, hit pause. So you can write down all the steps. Once you're done, hit play so we can move on to the next slide. Okay. The one part of this one I want to point out that we haven't had to talk about is when it says decide if I need to add or subtract in step number 5. Okay. That's going to depend on the sign of the last term, and then we're going to have to be careful with the factors and how we place them. And so notice that add or subtract is brought up again in step 6 because it does matter who is where. And so we're going to look at the same time about positives and negatives throughout the next one, just so you can see one that has subtraction, because we haven't had that yet. So with that, let's look at another one. If you were not done with getting your steps, hit pause, go back, rewind, hit pause, and then so you can work it out. So once again in this one, I'm going to put that leading term up top. Oops, didn't change away from the highlighter. And then I'll put my last term in the bottom. Then, once again, I'm going to go and multiply them together up here. So, what's something that's different about this problem that was not in the last one? I have subtraction, okay? Which means that's going to matter for my terms, because that means somehow they're not all going to be positive. So, let's look at our factors for 42 first. So 1 goes into 42 with 42. And then 2 goes into 42 by multiplying by 21. 3 goes into 42, what is that, 14 times? 4 does not go into 42, and neither does 5, but 6 does with 7. And so if you list them off numerically on one column, as soon as you hit two numbers that are side by side, you're good with listing off your factors. And so, because we checked all the numbers between 1 and 6, and then 7 happened on the other side, so I was good to stop. Just as a hint for, for when you have all of your factors. So, with that being said, that positive at the end means that both signs have to be the same because they multiply together. So when two negatives multiply, I get a positive, or when two positives multiply together, I get a positive. But that middle term, since the middle one had to be negative and the last one's positive, that means all of these numbers are negative. Okay, so when I go to add them together, I want to know which pair add to negative 17. So that pair happens to be my negative 3D and my negative 14D. So I have negative 3D and negative 14D. Okay, so in that first row, I have a D that's in common. And in my second row, well, we know that 14 is a factor of 42, so I do have a 14. In my first column, I have just a D. And in my second column, I have a 3. So I do have to be careful here, because before we just threw positives on there because I pulled out a positive 3. Well, negative 14 does go into 42, and so I can have a negative with that one, and a negative 3 does also go into 42. And so because of that, those are negative, so my final answer for this one is going to be D minus 3 and D minus 14. So let's FOIL this one out just to check it, because this one is so much weirder than the other ones we've done. So that's my final answer, but we are going to FOIL right quick to check. So my first terms would give me D squared. My last terms would give me minus 14D. My inner terms would give me negative 3D. And my last terms would give me positive 42. So these two middle terms do add to negative 17, which is what I wanted. So I am good, even though if it seemed a little bit tricky. So far we've always added our terms. So what makes me need to subtract them? Well, that's going to be when that last term is not positive. So notice now my 27 is negative. And so my last term, so I'll put my m squared up top and my negative 27 in the bottom. So I will have negative 27 m squared. So now I need to look at the factors of 27. And so that would give me a negative 1 and a positive 27, or 1 and a negative 27. And then I would have 2 doesn't go into it, 3 does. So I could have 3 and a negative 9, or a negative 3 and a positive 9. And those are all the factors of 27. So which ones then add together to give me 6? Because I already took care of all the signs and I wrote out double the number of factors, I can go add them, because 1 in each of these pairs is negative and 1 is not. So 27 plus negative 1 is positive 26. Negative 1 plus, then I would get negative 26. And so 3 minus 9 is negative 6. And then negative 3 plus 9 is positive 6. So in this case, I want the positive, so these are the ones I'm going to use. I forgot to write my m's with all of those. So this gives me a negative 3m and a 6m. So remember, my signs needed to be different, and so I'm going to get an m up top, and I'm going to get a 3 in the bottom, and I'll get an m in the first one, and then I will get a negative 3 in the second one. Well, I wrote a 6 instead of a 9, guys. I'm sorry. I knew something went wrong. So that's supposed to be a 9, not a 6. I wrote the 6 that I added them to. So 9 and negative 27 share a 9. And so because of that, we're going to have m plus 9 and m minus 3. So when that last term is negative, a little too much. When that last term is negative, what that means is that my signs are going to be different, and I have to pay attention as to who is who. First, in the last one, it was a positive, and so my signs were the same, which is why they were both negative, like that middle term. So just be careful with signs, because they can get pretty complicated with these. So I mentioned I was going to take you through looking at one of the ones that were in our, I said we had some different ones that were in our worksheet. So what I'm going to do is I'm going to use the n squared plus 8n minus 20 for us to go and look at another problem. And this will be our last one. And this is the other method that's used. It's a little more straightforward in some senses. And so I mentioned we're using the quadratic n squared plus 8n minus 20. Okay, so with this one, what we'll do is we're still going to multiply that first term and last term. So I would have negative 20n squared. And so just in a table, I'm going to write all my factors down. So in this first column, I'm going to write factors. And so that would be, let's see, I'd have negative 1 and 20, 20 and negative 1. And then what are my other factors? Let's see. Oh, we wouldn't actually use the n squared in this case, just the negative 20. We'll have negative 20 and 1. We'll have negative 2 and 10. And then 2 and negative 10. And then we can also have 5 and 4 and negative 5 and positive 4. And I think that's all of them. So in your first one, you'd have your factors. In this case, because I'm negative at the end, I'm going to have the difference between them. Okay. Or difference or sum. In this case, I've already put the signs with all of them, so I can just add them up, which makes it easy. So that would give me 19 or negative 19, 8 or negative 8, 1 or negative 1. And for this particular problem, I wanted positive 8. So what this tells me, because 1 is in front of my n squared, is that my factors should be my n times my n minus 2 and my n plus 8. So not n plus 8, I did that again, n plus 10. One thing we have to be careful about is this method does not work as well as our factors get more complicated. So we do want to be careful with it as we move forward. But now it's time to go onto Moodle to get your worksheet, which is today's homework, which is part 1 of your study guide for this section. You'll get part 2 tomorrow after we finish that lesson. Let me know if you have any questions.